Ladies and gentlemen, boys and girls, children of all ages. Today we're going to do some math. You guys done? Okay. Today we're going to do some multiplication problems. We're going to continue. I need you to know how to do multiplication problems that have a 2-digit factor. We're eventually going to have to know a 3-digit factor times a 2-digit factor. You need to know how to find the product. You need to know what all these words I'm using mean. If you're not getting this done correctly, please follow along and pay attention. Let's start with the first one, which is 45 times 77. (45 times 77). We're going to start by using the standard algorithm for each and every one, so that you see the standard algorithm. Oscar, turn your desk so you're facing me. So that you see the standard algorithm. Eventually you're going to need to know the standard algorithm. Okay, if it doesn't ask you to fill in the blanks, remember we've seen some problems on Prodigy and maybe Thinking of Math where you had to fill in where the blanks were. They use that mostly with the standard algorithm. If it doesn't ask you that, then you can solve it any of the ways you want to. The standard algorithm looks like this. Oscar, get your multiplication chart out because you're going to help me. But your name's not Oscar. I know you can.
You can get one.
I'll come back to you, Oscar. All right, Taylor. 7 times 5. Put your hands down.
35.
Good. Taylor's helping me with it. I put my 5 in my ones place. I carry my 3. Remember, in class, unless you are specifically told otherwise, use your multiplication chart. I don't need to see you counting on your fingers and toes. Use your multiplication chart. That's what it's there for. That's why I gave it to you. You should be studying it, memorizing it, or getting a tattoo of it. But not on your face, because then you won't be able to see it. I'm not advocating that you get a tattoo. It's illegal until you're 18.
Actually, if your parents sign it, you can.
It's at 16, if your parents sign. All right, so forget about the tattoo. We put our 5 in our ones place. We carry our 3. Taylor, what is 7 times 4? Plus 3 more. 28, 29, 30, 31. 31. So 7 times 45 is 315. Oscar, you follow me? Okay? We are done with our ones place. We are done with what I carried here. We are starting in our tens place. So this number needs to have a 0 in the ones place since we're starting in the tens place. What is 7 times 5? Taylor.
It is 35.
35. You notice these 2 digits are the same, right? So I'm going to have the same numbers here plus the 0 at the end. So I'm going to have 3, 1, 5, 0. So 70 times 45 is 3,150. Oscar, you with me? Mm-hmm. Now we add. 5 plus 0 is? 5. 1 plus 5 is? 6. 3 plus 1 is? 4. 3 plus nothing else? 3. All right, so we get a product of 3,465. 3,465. First, we're going to do it one of the other ways, and then we're going to check it with division. So follow along. If you struggle with the standard algorithm, then work it one of the other ways. If you struggle with the standard algorithm, work it one of the other ways. Okay, so let's take what they call the box method. What they call the box method. You're going to have the same number of columns. So our first factor is 45, so 40 and 5. Think of an expanded form. In expanded form, you would just make 40 plus 5. Think of it as the value. What is the value of the 4? What place value is the 4 in? 10. What does 4 tens equal? 40. Okay, that's where I got my 40. What place value is the 5 in? 1. What is 5 ones? 5. That's where I got it. Okay, our second factor is 77. What place value is this first 7? Okay? Okay, 1. So I have a 7 here. What about the next 7? Tens. So it's worth 70. Okay, so if you like this method, you may want to write it down as we're going through it. If you struggle with this method and you like this method, maybe write it down, keep it in your journal. Don't get a tattoo of it because that would be bad. Don't tell your parents I told you to get tattoos. They'll get mad at me. And then it's simple. It's just like a multiplication chart. You take the number on the top, the number on the side, and where those two numbers would meet, then that's where you're going to multiply. So this box, I'm multiplying 70 times 40. I have my 0 rule. I have a 0 at the end of 40 and a 0 at the end of 70. So if I put my 2 zeros in, then all I have to do is multiply 4 times 7, which is 28. So 40 times 70 is 2,800. Okay? Again, put my zeros in, multiply my tens place. This one meets right here in this box. And it has a 5 on the top and a 70 on the side. I can put one of my zeros in. Put one of my zeros in. Then all I have to do is multiply 7 times 5, which is 35. So 70 times 5 is 350. Okay, anytime you have a 0 at the end, it makes life really easy. Really easy. Okay? Then I'm going to where these two numbers meet. I have a 40 and a 7. 40 has a 0 at the end. So I can put 0 there. What is 7 times 4? 28. Notice how this one is different than this one. Okay? It has one less 0. Why? Why does this 280 and this 2,800? Alexander?
Because in 40 times 70, there's 2 zeros.
Because 40 times 70, there's 2 zeros. In 40 times 7, there's just 1 0. Okay, that's why those two are different. And then, where the 5 and the 7 meets here, what's 5 times 7? 35. 5 times 7 is 35. Okay, so now, any ideas what we do next? Kayla. Add. Kaylee. Kayla, I said it right the first time. Why'd you look at me crazy? Okay. So then we add them together. We add from every box 2,800, 350, 280, and 35. And if we did this correctly and we did this correctly, they should be the same number. Okay? So 0 plus 0 plus 0 plus 5 is?
5.
0 plus 5 plus 8 is plus 3? 16. What I would do is I'd add my 5 plus 3 is 8, and then add my 8 in because I know 8 plus 8 is 16. So I put down my 6, carry my 1. Now what I would do is I would add 8 plus 2 because that equals 10. 10 plus 3 is 13, plus 1 is 14. That's kind of finding compatible numbers, numbers that go together that I can add real easy. 2 plus 1 is 3. 3,465. Okay? So either way, if you like this way, use this way. My only goal is for you to get it right. That's it. If you like this way, use this way. If you like this way, use this way. All right, now, before we move on to our next problem, I want to demonstrate how to check a multiplication problem. And how do you check a multiplication problem? Division. What's that called? It's a what kind of operation? Inverse operation. Division is the inverse operation of multiplication. So now what I do is I take my product. My product is 3,465. And I'm going to divide that by either one of my factors. Do you want to divide it by 77 or 45?
45.
45. I would always choose the lesser one too. And if we did our multiplication correctly, we want our division to be the other factor, the one we didn't put here. So if we did it correctly, we want our quotient to the division problem to be 77. Okay, next week we start on double-digit division. So again, it's very important. So watch this video when you're at home and you will learn muchos, cosas, many things.
Yeah, maybe.
Many things. All right, does 45 go into 3?
Yeah.
No. I'm not going to have a number above the 3. Does 45 go into 34? No. I'm not going to have a number in the hundreds place. Does 45 go into 346? Yes. I'm going to have a number above the tens place and a number above the fives place. My answer is a 2-digit number.
Five's place.
The ones place. Sorry, I was looking at the 5. Tens place and the ones place. My answer is a 2-digit number. Now what I see kids do wrong is you want to take 45 and figure out how many times it goes into the whole thing. And that's going to mean you're going to end up multiplying by 77. And you're just going to keep guessing and checking. But I only have to take it in one place value at a time. It's going to go into 346. So I need to see how many times 45 will go into 346. How many times do we think 45 is going to go into 346?
I have a guess of maybe 7 times.
She has a guess of maybe 7 times, which is a very intelligent guess, because if we did this right, we want our answer to be 77. Okay? That's a very intelligent guess. Olivia, what is 7 times 5?
35.
35. Olivia, what is 7 times 4?
28.
Plus 3?
31.
31. So now I know 45 times 7 is 315. Okay? So I put my 7 in the tens place. 7 times 45 is 315. Now, I'm smart that I'm not going to erase my work, because I may need to know later what 45 times 7 is. So I like to leave my work on my paper. Maybe another problem down the road has a 45 times 7 in it, and I'll be able to look at it and not do it. So keeping your work on your paper, on your dry erase board, where you're writing it on your desk, may save your life one day. It might, really. So then I subtract. 6 minus 5 is 1. 4 minus 1 is 3. That's a 0. Is that number, is my difference here okay?
Yeah.
31 is okay. How do we know it's okay? After I subtract, my difference has to be smaller than what? My divisor. I can't have, when I subtract, I can't have a number greater than 45. If I have a number equal to or greater than 45, this number in my quotient needs to be bigger. Make pennies?
Yep.
Okay. I bring down my 5 in my ones place. I need to see how many times 45 goes into 315. Class, what do we think?
7.
7 times. And I know that because I didn't erase my work. So many times I see you You do a multiplication, you cross it out, and then you need it again. Don't cross it out because you may need it again. 7 times 45 is 315. We subtract, we get 0. So we have no remainder whatsoever. No remainder, Nevaeh. No remainder whatsoever. You with me? You got it? Ethan, you okay?
Yeah.
Isaac, you okay?
Yeah.
All right. Let's look at our second one, which is 19 times 26. Again, we're going to solve this the standard algorithm. So just the regular way you do it. We're going to solve it the standard algorithm. So we're going to start with our ones place. Hunter, what is 6 times 9? Isn't you open up to the multiplication chart on your paper?
Yeah.
Well then look what 6 times 9 is. 54. I put my 4 in my ones place. If I have 54 ones, if you have 54 $1 bills, your purse will not be able to close, your wallet will not be able to close. So you go to the bank and you say, can you give me 5 tens? So I take my 54 $1 bills, I keep 4 $1 bills, and I put my 5 in my tens place. I know it's crazy, but that's what I do. Hunter, 6 times 1.
6.
Plus 5. 11. Okay, I don't have anywhere else to, so I have 11 tens. That's saying, same thing as saying, 11 tens would be how much? $110. Okay, so I got to carry this over here because that adds up to 11. I don't have anything else to carry over. Joseph, you with me? Because the only reason I ask is because you're drawing a robot instead of watching me. And while robots are cool, they're not very helpful to multiplication. Well, drawing robots is not helpful in multiplication. Maybe a real robot would be. I don't know. I've never owned one. All I've done is I've seen the Jetsons. So, oh, it's an old cartoon. Go back and watch it. All right, I'm done with what I carried. I'm done with my ones place. So now I'm multiplying by my tens place. That means I got to start in my tens place. Yes, sir. You may go potty, Evan. You can wait. All right, so now we're multiplying 2 times 9, Hunter. 18. I put my 8 in my tens place. I have 18 tens. It's the same as saying 108 tens. So I put my 1 over here. 2 times 1 is?
2.
Plus 1 is? 3. We add. 4 plus 0 is 4. 8 plus 1 is 9. 3 plus 1 is? 4. Does that sound about right?
Yes.
Okay, sounds about right. If I rounded it, I could do 20 times 30 or 20 times 25 or something like that and make it easy. Okay, round it and I could tell my answer that way. Now Dominic specifically asked me if we could go over the lattice method today. Well, Dominic, we can. We can, Dominic. So, the lattice method is also with drawing boxes. And I've seen a lot of you already know the lattice method. You already know the lattice method. A little different than the box method we just showed. And you put 1 digit over each place. Each row or each column has a digit. Each row has a digit. Each column has a digit. Each row has a digit. And again, if you know your 0s through 9s, if you had a times table that was just 0 through 9, you'd be excellent no matter how big the number was. If you memorize your 0 through 9s, you would be excellent no matter how big the number was. The people not good at math are not even paying attention when we do our multiplication review at the beginning of class. I'm just saying. I'm just saying. I'm only saying, Ruben. All right. And again, just like a multiplication table, 2 and 1 meet here. What's 2 times 1? 2. So I put a 0 and I put a 2. I put a 0 and I put a 2. 9 and 2 meet in this box. What's 9 times 2?
18.
18. 1 above the line, 8 below the line. 1 and 6 meet here. What's 1 times 6?
6.
6. A 0 above the line and a 6 below the line. Oscar, I'm seriously concerned that you don't pay attention. It hurts my feelings.
Once in a while, everything my world gets misery.
All right. That's a good movie, too, if you've never watched it. Misery. It's a Stephen King movie. It's
Oh, it is.
really kind of creepy.
Never heard of it. Steve King.
9 times 6 is
54.
54. Then it is simple addition. Then it is simple addition. I add each diagonal up. That diagonal just has a 4 in it. Okay, and I know yesterday they put those little cups on it. That diagonal has a 4 in it. That's going to keep your numbers separated. This diagonal has a 8, 6, and 5. I know 8 and 6 equals 14, just because I know. So I would keep that. I'd do those two first. 14 plus 5 I know equals 19. So I'd put a 9 here. I'd carry my 1. I do this diagonal. 2 plus 1 plus 1 is 4. And all I have in this top diagonal is a 0, so I need to put that down. So I got 494 here. I got 494 here. So it looks like we've done our answer correctly. That's what it looks like. Yes, ma'am.
I got 394. Oh, I know.
Did you get, how did you do it?
I did lattice.
Lattice? Did you get 2 in this box? Did you get 18 in this box?
I got a 6 because I did 19 on the other side and 26 on top.
Okay, well, let's do it that way. So you did 26 on the top. And 19 on the side. We divide it here. This box should be a 2. You get a 2 there. This box should be a 6. You get a 6 there.
Yes.
This box should be 54. Did you get a 54 there? And this box should be 2.
2.
Yeah. Oh, I'm sorry, 9 times 6 should be 18. My bad. Okay, is that what yours looks like? Okay, that diagonal we know is a 4. This diagonal is 6 plus 5 plus 8, which is 6 plus 5 is 14, or 6 plus 8 is 14, plus 5 is 19. So I put a 9. I bet what you didn't do is carry your 1 from 19. 1 plus 2 plus 1 is 4. So my guess is you didn't carry your 1. Okay? Let's check it with division, because we're starting division next week and you need to know how to divide with 2-digit divisors. I'm going to take my smaller of my 2 factors, which is 19, which 19 is close to 20 and I can count by 20s. I just imagine if I had a different job than teaching, that people would just be handing me $20 bills and I know how to count those. I don't have a different job than teaching, so really people only hand me $1 bills.
You could become the president.
I could.
You'd be an awesome one.
All right, then I take my product, which is 494. My 19 is my divisor. My 494 is my dividend. And I want my quotient to equal what?
26.
26. I want my quotient to equal the other factor. If I did my work right, I want my quotient to equal the other factor.
Okay.
Does 19 go into 4?
No.
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 I will not have a number over the 4. Does 19 go into 49?
Yes.
Yes.
Yes, it does.
I'm going to have a number in the tens place. I'm going to have a number in the ones place. the biggest mistake I see when kids are doing the division is they put their numbers over the wrong thing. Your numbers have to be directly over whatever place value you're putting them in. So this number is going into the 49, so it's going into the tens place. My number needs to be directly above the 9. That's the biggest mistake I see. And if you put your number over the wrong thing, you either leave a 0 out or you get some crazy cattywampus answer. Okay? Let's count by 20s. Count by 20s. And I want to get as close to 49 as I can without going over. So 20, 40, 60. So 3 is going to be way too big. So probably 2. I don't know my 19 times tables. I could figure it out by multiplying 20 times 2 and then subtracting 2. But hey, I'm going to do 19 times 2. 38. Oh, that's 18, sorry. 9 times 2 is 18, 2, 3. So that's 38. I subtract. Again, hundreds over hundreds, tens over tens. That's a 1, that's a 1, and I bring down my 4. Now, I don't know my 19's times tables, but 19's close to 20, so I can count by 20, 40, 60, 80, 100, 120. Well, that's too big, so let's try 5. Let's try 19 times 5. That's 45, 4. Gentlemen, are you over there paying attention to me? 5 times 1 is 5, plus 4 is 95. So let's try 19 times 5, which is 95. Can I subtract 5 from 4?
No.
No, that's crazy. I can't do that. I borrow from my tens place. I take a 10 and give it to the ones. So if I'm taking 110 and giving it to 4, then I have 14. 14 minus 5 is... Anybody help me out?
No.
9. Good, 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 good. I'm a little slow. Then I have... Now, I don't need to borrow from this 1. This is what I also see what kids doing. What is this number right here if I just look at this 2 digits? 10. Now what I see a lot of you doing is going, oh, I can't do 0 minus 9, so I borrow from the 1 and I make this 10 a 10. It's already a 10. 10 minus 9 is 1.
No.
So is this correct?
No.
No. Why not?
I know.
Evan knows. Tell me, Evan.
Because you can get another group.
Good, I can get another group. If my difference, when I subtract, is equal to or greater than my divisor, then I need to recheck my work. And since this is exactly equal to 19, I know I need to have 19 times 6. Okay, 19 times 6, and that's going to be my answer. 26. It was 26 over here. Questions? So you've learned, we've studied the standard algorithm, at least those of you that paid attention did. We've studied the box method, which those of you that paid attention did. We did the lattice method, for those of you that paid attention. And we did division with 2-digit divisors, for those of you that paid attention. So if you watched, you got a lot out of this. Kayla, in just a moment. I'd like to turn off the video before I send people potty. Evan told me he was going to wet himself if he didn't get to go then. Boom! Shakalaka! Love y'all. Have a blessed day.